In this video, we'll be using the derivative to find the relative extrema of a function. If the derivative changes from negative to positive at some value c, then f of c is a relative minimum. The derivative is the slope of the tangent line, so if we have a tangent line with a negative slope, and then that changes to a tangent line with a positive slope, then f of c is going to be a relative minimum. If the derivative changes from positive to negative at c, then f of c is a relative maximum. So the slope of our tangent line is changing from positive to negative, so we have a max. And then if f prime of x does not change sign at c, then f of c is neither a relative min nor a relative max. The example that we'll be working with, we're asked to find the relative extrema of the function f of x equals the quantity x to the fourth plus 1 divided by x squared. Our first step is to find the critical numbers of this function, and we do that by finding the derivative of f and then setting that equal to 0. So our derivative is, we'll use the quotient rule, x squared times the derivative of the numerator, which is 4x cubed, subtract the numerator times the derivative of the denominator, and that's all divided by the denominator squared. And let's simplify this fraction. We are setting it equal to 0. We have 4x to the fifth minus 2x to the fifth minus 2x all over x to the fourth. So let's see, combine like terms. We have 2x to the fifth minus 2x all over x to the fourth. Let's factor out 2x. And we have x to the fourth minus 1 over x to the fourth. And we can take this x factor and cancel with one of these. So this becomes 2 times the quantity x to the fourth minus 1 over x cubed. And that's equal to 0. Our critical numbers occur when our derivative is equal to 0, and that'll happen when the numerator is 0. So 2 times x to the fourth minus 1 equals 0. This is the difference of squares, so we'll factor x squared plus 1, x squared minus 1. And then this factors further, so we have 2x squared plus 1, x plus 1, x minus 1 equals 0. So this factor will never equal 0, but we can get x equal to negative 1 and x equal to positive 1. We also have a critical number when the derivative does not exist. So f prime does not exist. when x equals 0. So that's another critical number that we're going to need to check. So our real numbers are divided into 4 intervals. -1, 0, and 1 are the critical numbers that divide those. We'll need to pick test values in each of these intervals. Let's pick -2 in this interval, -1/2, and a +1/2, and +2. And then we want to figure out the sign of the derivative in each of these intervals by plugging in the test value. So f prime at -2, f prime at -1/2, f prime at 1/2, and f prime at 2. I'm going to go ahead and enter just this one. Don't have to worry about it being simplified. So the quantity 2x raised to the 5th power, 2x, divided by x to the 4th power. And let's store -2, -3.75, and we can store a -1/2, and get 15. Store +1/2, and we get -15, and then store 2, we get 3.75. So our derivative is negative in this interval and positive in this interval. So this critical number may represent a minimum. Our derivative in this interval is positive. Our derivative in this interval is negative. So this critical number may represent a max. And our derivative in this interval is negative. Our derivative in this interval is positive. So this critical number may represent a minimum. So let's find the values of our function at each of these critical numbers. So f of -1, f of 0, and f of 1. Our function was x to the 4th power plus 1 over x squared. Notice that at 0, when x is 0, our function is undefined. So this is an asymptote. We're not going to have a maximum because we have an asymptote at x equals 0. And we can put in -1. -1 to the 4th power is 1. So we have 1 plus 1 is 2 over 1. So this value is 2. And also when we put 1 in, we get 2 over 1, which is 2. So we have just minimums, relative min at -1, 2, and 1, 2.